Good morning. My topic is all about software architecture. So, what is a software architecture? Software architecture is process of designing the global organization of a software system, including dividing software into subsystems, deciding how these will interact, and determining their interfaces. The architecture is the core of design, so all software engineers need to understand it. The architecture will often constrain the overall efficiency, reusability, and maintainability of a system. The importance of software architecture. Why we need to develop an architectural model? Of course, to enable everyone to better understand the system, to allow people to work on individual pieces of the system in isolation, to prepare for extension of the system, and to facilitate reuse and reusability of our system. So, contents of a good architectural model. A system architecture will often be expressed in the terms of several different views. First is the logical breakdown into subsystem, the interfaces among the subsystem, the dynamics of the interaction among component at runtime, the data that will be shared among the subsystem, and the components that will exist at runtime or devices on which they will be located. So design stable architecture to ensure the maintainability and reliability of a system. An architecture model must be designed to be stable. Of course, being stable means that the new features can be easily added with only small changes to the uh, architecture. So, in developing a system, we must to design to be stable po yung ating system para wala tayong magiging problema. And of course, we must to uh, update new features no, para po ma-add sa ating system or mapaganda. So, developing an architectural model, of course, start by sketching an outline of the architecture. So, based on the principal requirements and use cases, determine the main components that will be needed. Choose among the various architectural pattern, of course, discussed, and suggestion. Have several different teams independently develop a first draft of the architecture and merge together the best idea. Of course po, sa pag-develop ng system, no, we need po yung uh, idea ng isang team para po ma-ensure po yung pagiging reusability and papaganda po yung ating system. So, refine the architecture. Identify the main ways in which the components will interact and the interfaces between them. And decide how each piece of data and functionality will be distributed among the various components. And of course, determine if you can reuse an existing framework, if you can build a framework. Siyempre, i-consider po natin no, yung use of cases and adjust the architectural or architecture to make it realizable, and of course, mature the architecture. So describing an architecture using UML. All UML diagrams can be useful to describe aspects of the architectural model. Uh, we have four UML diagrams are particularly suitable for the architecture modeling. We have a package diagrams, a subsystem diagrams, component diagrams, and deployment diagrams. This is the example of the package diagrams. We have a client common folders, import into client server folder. So component diagrams, we have a client, and of course communication, and bound into server. So in deployment diagram, we have a GPS devices, and of course we have a wireless communication bound into machine or client. So bound into TCP IP and uh, bound into machine or server. So architectural patterns. The notion of patterns can be applied to software architecture. These are called architectural patterns or architectural styles. Each allows you to design flexible system using components. The components are as an independent of each others are as possible. So the multi-layer architectural patterns. In a layer system, each layer communicates only with the layers immediately below it. Each layer has a well-defined interface used by the layer immediately above. The higher layer sees the lower layer as a set of services. So a complex system can be built by superposing layers at increasing levels of abstraction. It is important to have a separate layer for the UI. Layers immediately below the UI layer provide the application functions determined by the use cases. Bottom layers provide general services, for example, uh, network communication and database access. So we have a multi-layer architecture design principles. First, divide and conquer. The layers can be independently uh, designed, so increase cohesion. Well-designed layers have layer cohesion. Just coupling well-designed lower layers do not know about the higher layers, and the only connection between layers is through the API. So increase the abstraction. You do not need to know the details of how the lower layers are implemented. So increase the reusability. The lower layers can be often be designed generically. Of course, we have increased reuse. Uh, you can often reuse layers built by others that um, provide the services that we need. So increase flexibility. We can add new facilities built on lower level services or replace higher level layers. Anticipate obsolescence by isolating components in separate layers. The system becomes more resistant to be obsolescence. Design for portability. All the dependent facilities can be isolated in one of the lower layers. Design for testability. Siyempre po sa pagdidesign po, uh, we need to test po each modules po, no? And designed defensively, the APIs of players are natural places to build in rigorous assertion checking. So the client server and other distributed architectural patterns. There is at least one component that has the role of server, waiting for and then handling connections. There is at least one component that has the role of client, initiating connection in order to obtain some service. A further extension is the peer-to-peer pattern, a system composed of various software components that are distributed over several hosts. So this is the example of a distributed system. Of course, we have a network and database server, workstation, and output services. So the distributed architectural design principle. So in divide and conquer, dividing the system into client and server processes is a strong way to divide the system. Each can be separately developed. So increase cohesion, the server can be provide a cohesion service, of course, into client. So reduce coupling, there's usually only one communication channel, exchanging simple messages. And increase abstraction, we have separate distributed components are often good abstractions. Increase reuse, it is often possible to find suitable frameworks on which to build a good distributed system. However, a client-server system are often very application specific. In design for flexibility, of course, distributed system can often be easily reconfigured by adding extra servers or clients. Design for portability, we can write clients for new platforms without having to port the server. In design for testability, we can test or you can test clients and servers independently. In design defensively, you can put rigorous checking in the message handling code. The broker architectural pattern. Transparently distribute aspects of the software system to different nodes. An object can call methods of another object without knowing that this object is remotely located. Corba or CORBA is a well-known open standard that allows to build this kind of architecture. So this is the example of a broker system. Of course, we have a client, a proxy, and we have an object request, broker, and a remote object. The broker architecture and design principles. In dividing and conquer, the remote objects can be independently designed. Increase reusability. It's often possible to design the remote objects so that other systems can use them. To increase uh, the reuse, you may be able to reuse remote objects that uh, others have created. So design for flexibility, the brokers can be updated as required, or the proxy can communicate with a different remote object. And design for portability, We can write lines for new platforms while still accessing brokers and remote objects on other platforms. In defensively, we can provide careful assertion, checking in the remote objects. The transaction processing architectural patterns. A process reads a series of input one by one. So each input describes a transaction, a command that typically some change to the data stored by the system. So there is a transaction dispatcher component that decides how to do with each transaction. These dispatches produce call or message to one of a series of components that will handle the transactions. So the transaction processing architecture and design principle. In divide and conquer, the transaction handlers are a suitable system division that you or that we can give to separate software engineers. Increase cohesion. Of course, transaction handlers are a naturally cohesive unit. Reduce coupling, separate the dispatcher from the handlers tends to reduce the coupling. Design for flexibility. Uh, we can readily add new transaction handlers. So design defensively, you can add assertion, checking each transaction handlers or in the dispatcher. The pipe and filter architectural pattern. This is a stream of data in relatively simple format is passed through a series of processes, each of which transform it in some way. Data is constantly fed into the pipeline. The process work concurrently, and the architecture is very flexible. Almost all the components could be removed. Components could be replaced. New components could be inserted. Certain components could be reordered. So this is the principle of pipe and filter architecture and design. So in divide and conquer, the separate processes can be independently designed. Increase cohesion, the processes have functional cohesion. Reduce coupling, the processes have only one input and one output. Increase abstraction, the pipeline components are often good abstraction, hiding their internal details. Increase reusability, the process can often be used in many different contexts. In increased reuse, it is often possible to find reusable components to insert into a pipeline. So, design for flexibility. There are several ways in which the system is flexible. In testability, it is a normal easy to test the individual process. Uh, Design defensively, we can rigorously check the inputs of each component or check the each module, or else you can use design by contract. So the model view controller or MVC architectural patterns. An architectural pattern is used to help separate the user interface layer from other parts of the system. The model contains the underlying classes, whose instances are to be viewed and manipulated. The views contains object used to render appearance of the data from the modules, the user interface. The controller contains the objects that control and handle the user's interaction with the view and the model. The observable design pattern is normally used to separate the model from the view. So this is the example of MVC architecture for the UI. So we have a controller, view, model, and bound into a uh, in the database. The example of MVC in web architecture. The view components generates the HTML codes to be displayed by the browser. The controller is the component that interprets HTTP post transmissions coming back from the browser. The model is the underlying system that manages the information. The MVC architecture and design principles. In Divide and Conquer, the three components can be somewhat independently designed. Increased cohesion, the components have stronger layer cohesion than if the view and controller were together in a single UI layer. Reduce coupling, the communication channel between the three components are minimal. Increased reuse, the view and controller normally make extensive use of reusability components for various kinds of UI control. Designed for flexibility, it's usually quite easy to change the UI by changing the view, the controller, or both. Design for testability, we can test the application separately from the UI. The service-oriented architectural pattern. This architecture organizes an application as a collection of services that communicates uh, using well-defined interface. In the context of the internet, the services are called web services. And of course, a web services is an application. We all know accessible through the internet that can be integrated with other services to form a complete system. The different components generally communicate with each other using open standard such as XML. This is the example of service-oriented application. We have a service uh, consumers. Now we have is service bus, and under a service bus, we have a configuration and rules, management and reporting, and service interface and service implementations. So, service-oriented architecture and design principle. Divide and conquer, the application is made of independently designed services. So, in increased cohesion, the web services are structured as layers and generally have good functional cohesion. Reduce coupling. Web-based applications are loosely coupled, built by binding together distributed components. Increase reusability. A web service is highly reusable components. Increase reuse. A web-based application are built by reusing existing web services. Anticipate obsolescence. Obsolete service can be replaced by new implementation without impacting the application that use them. In design for portability, a service can be implemented on any platform that supports the required standards. Design for testability. Of course, each service can be tested independently. So design defensively, a web service enforce defensive design since the different application can access the other service. So the message-oriented architectural patterns. Under this architecture, the different subsystems communicate and collaborate to accomplish some tasks only by exchanging messages, also known as message-oriented middleware or MOM. The core of this architecture is an application-to-application messaging system. Senders or receivers need only to know what are the message formats. In addition, the communicating application do not have to be available at the same time. Message can be made persistent. The self-contained messages are sent by one component, the publisher, through virtual channel to which other tested software components can subscribe or the subscribers. So the message-oriented architecture and design principle. In divide and conquer, the application is made of isolated software components. The components are loosely coupled since they are shared only data formats. Increased abstraction, the prescribed formats of the message are generally simple to manipulate. And of course, all the application details being hidden behind the messaging system. Increased reusability. A component will be reusable if the message formats are flexible enough. So increased reuse, the components can be reused as long as the new system adhere to proposed message formats. So design for flexibility. The functionality of a message-oriented system could be easily updated or enhanced by adding or replacing components in the system. So design for testability. Each component can be tested uh, independently also. So design defensively. Defensive design consists simple of validating all received messages before processing them. So these my references and all. Uh, thank you.